Welcome
Okay.
back. Okay, go ahead, sorry.
You're first up.
I was just going to welcome everybody back for day 2 of the SAC meeting, the South American African Astronomy Coordinating Committee meeting. Day 2, we will have the network operators provide reports and updates on work that they've done since our meeting last year, as well as provide information on their roadmaps for the next several years. Yes, yes. Good morning. Bom dia. So we'll go ahead and start off with the AmLight project. And we will have presentations from all the different network operators operating in South America, Africa, and in the US involved with the support of the science projects. Okay, with that said, Geronimo, are you ready to get started? Can't hear you. Are you muted?
See, I said that I was ready, but I was not. I was using the wrong microphone. So I'm ready now, I think.
Okay, the floor is yours.
Let me try to share my screen. Do you see the PowerPoint in presenter mode?
Not yet. We
I
see
see
your
it.
slides on the left.
Oh yeah, it's not a presenter mode.
Yeah, that's the presenter mode. I'll keep this way. Otherwise, I'll lose control of my screen. Well, good morning, everyone. My name is Geronimo Bezerra. I'm a Chief Network Engineer here for the AmLight project. Julio presented a lot about what AmLight is, but I'm still going to recap for those who were not in the meeting yesterday. So this will be the outline for the presentation today. I'm going to start with what is AmLight, a little bit about network connectivity, not the things that changes from last year because not much changed, but we're planning to change for the rest of this year. A little bit about network provisioning operation and how this architect or this structure that we're building is going to support the SAC community, and a little bit of conclusion. So again, for those who are not familiar, AmLight is a distributed academic exchange point. It's built to enable collaboration among Latin America, Africa, and US. It's supported by National Science Foundation, OAC, and RNC program. This is the award number 2029-283 for the time period of time frame of 2021-2025. And AmLight is built upon partnership with all those research and education networks that you see on the right side, FIU, RNP, Red Nasp, Red Claro, UNA, Aura, Tenet, Semren, FLR, and Internet 2, and all of them like somehow share infrastructure resources or human resources. And talking specifically about the AmLight EXP project, the 2021-2025, this is the vision that we have, is continuing enabling collaboration among researchers and network operators in Latin America, and Africa, and US by providing reliable, sustainable, scalable, and high-performance network connectivity and services. And specifically for this time frame, we have those 5 activities as the main focus: supporting service level agreement-driven applications, improving network visibility and management, enabling integration between AmLight network and the network-aware science drivers, adding network and cloud services, and the main one that we see is minimizing the human role in network operation. So now let me talk a little bit about network connectivity. So this is the figure. I hope you all can see this, this figure here on the right side. It has basically 3 colors. I'm going to talk about those 3 colors, but this is the topology we're talking about. Currently, we have 600 gigabits per second of upstream capacity between the US and Latin America, and 100 gigabit per second links going to Africa. For 2023, under the scope of this project, we're adding another 200 gigabit per second This is going to be between São Paulo and Boca Raton. So in total, in 2023, we plan to wrap that year with 800 gigabits per second of upstream capacity. But if you look at all the international connectivity, all the links are provided by all the participating of the consortium. We have more than 2 terabits per second of international connectivity. Here in this figure on the right side, we have those three colors. The green or yellow color represents the M-Light Express, which is basically spectrum or waves that we have over submarine cable systems or terrestrial systems. The white part represents the protected, which is a leased service, so it's a leased 100 gig ring going from Miami to Fortaleza, São Paulo, Santiago, Panama, San Juan, back to Miami. And also our partner Rede Clara that's going to be presenting later. They're also connecting Panama to Fortaleza. And since we share resources, we're going to have access to that infrastructure. And then we're going to adding more resilience to our network. So we're going to be splitting this ring into 2 rings, the north ring and the south ring. So users, for example, in San Juan or Panama, if they have a problem going north, they don't have to go all the way back to Santiago. So they can go directly from Fortaleza and then back to the US. And we have several points of presence. We have 3 in Florida, 2 in Brazil, 1 in Chile, 1 in Puerto Rico, 1 in Panama, and 1 in South Africa. And this year, 2022, we're expanding this network to Atlanta. So that's where you see this is a dashed line and the asterisks. That this is what we're working on right now. So we're planning to add 400 gig from Florida to Atlanta. It's going to be 300 gigs from Boca to Atlanta using the spectrum. And then it's going to be 100 gigs from Jacksonville to Atlanta, leveraging Internet 2 Layer 1 network. And one of the things we plan to do in Atlanta is to have dedicated connections to ESNet and Fabric that was mentioned yesterday. So this is the collaboration that we have. Is just to show how each one of those partners provide resources that build the whole network. You can see that some cities we have backhauls provided by Reuna or provided by Red Nasp or provided by RNP. And sometimes we ignore. When we have a city, everyone thinks everything in the city goes to the same data center. And that's not the case when you work with multiple submarine cable providers. So in Fortaleza alone, we're talking about 4 to 5 cables that we have access. So those cables, not 2 of them land on the same data center. So a backhaul is mandatory connecting all those sites. We don't want this to be completely disconnected. So this shows the power collaboration. And this is just a summary of the capacity that we have in between those locations. But in this case, it's more like a country to country. Well, although I have Florida and Georgia here, since those are new things. So in green, everything that is new, for example, this connection from Florida to Georgia, and from Panama to Brazil, provided by Rede Clara. And in blue, the ones that we plan to expand. So Brazil to Florida, currently we have 400 gig. And we're going to expand with another 200, totaling 600 gigabits per second. So now talking about provisioning, as you can see, again, back in this topology, there is a complexity involved, right? So there's a lot of resources, there's a lot of data centers, there are a lot of sites and switches and ports and links. So how we're managing all of this. One of the things that we did was back in 2014, this was even before the previous M-Light EXP project. That was the M-Light project from 2010 to 2014. We built we switched to this context or this paradigm called SDN, or software defined networking. And SDN is basically a software that manages the physical layer. And following some specifications, has this kind of this framework that we see here on the right side. You have an application layer, have a control plane layer, you have a management plane, and then you have a data plane. So what we did in the past was that we had software that was managing all the virtual layers, like the software layers, application control, and management. And then we had a blend of vendors for data plane. So we're expanding the networking, adding 100 gigs, replacing switches as we went along, because no single vendor had all the functionalities that we wanted. and then end up having mix of support. Some switches support some features and other switches are more focused as SDN. Some were like partially supporting SDN. So this was adding a complexity, but it was still working. And that forced us to have multiple southbound interface or multiple protocols to manage this physical layer. The main ones being OpenFlow 1.0 and OpenFlow 1.3. And this software, this SDN framework, was responsible for provisioning layer 2 VPN services, handling fiber cuts or device outages or power outages by finding backup path. But one of the challenges that we had, and that's the reason that I emphasize this, is the load balance had to be performed manually. So a lot of the activities to improve or to optimize the environment were done manually. And that's where the new project kicks in and then has a different focus. So for this new architecture that we're planning for 2021, 2025, the idea is that we have software that is specialized in each one of those planes. And then we created specialized planes like documentation plane or intelligence plane that would support or add new functionalities that we never had, but the main one being the intelligence plane. So we wanted to, all those activities that are used to be mainly human driven, now we want them to be completely automated. And we wanted to do this in a sub-second kind of approach. So we're moving towards this closed loop control approach, where the intelligence plane would be collecting very granular telemetry from the management plane and sending instructions back to the control plane that will push those to the data plane. So it kind of creates a loop that you just have to provide policies in different format, like almost human format policies. And then the software, the intelligence plane will convert those into instructions that are going to be used by the network devices. So we added this new the brand new intelligence plane that basically will consume these reports provided by the new management plane that leverages in-band network telemetry. And Nata is going to talk about this tomorrow about INT, but just keep in mind INT is like you have the functionality of now capability of monitoring every single packet and every single device, and then you know exactly how things are working in network. So this kind of visibility enables us to do this sub-second closed loop control. One of the things that we're doing is that the control plane, the software, the architect for this whole solution was entirely refactored from scratch, and now we're moving towards like a solution that was also open source. And then we call the Kitus MG. I'm going to talk about this in the next slide. And the data plane now is going to be uniform. Instead of having a blend of vendors, now the idea is to have just programmable switches, and those programmable switches will support the telemetry they're looking for. So in terms of control plane, we have this Kitus MG, which is the next generation of the Kitus SDN platform, is maintained by FIU and NESP since last year. It remains open source. We released the first code in February this year. And the main difference from the previous SDN platform is that this one is very focused on the MLite operation requirements or the user or the SAC community requirements. The main one being like the Pathfinder. We have now different ways of finding paths that are not just by bandwidth or by number of hops or delay. We combine all those metrics that you see on the screen to enable researchers to play with the network, but we don't want them to explicitly say what the path they want. We want them to say what they need. And then our intelligence plane and our control plane will find the proper path for that. So this enables, for example, I don't want to go through any specific country, or I don't want to go through any specific manufacturer. I don't want to go through a link. I don't want to back up. I don't want to go through a link that has high utilization or is not reliable. So there's a lot of things that you can play with to find a path. Obviously, the control plane needs to enable the INT monitoring, so the telemetry monitoring. This is done by this new version, supports bandwidth reservation, and supports multiple southbound protocols. So the data plane, as I mentioned, we are changing everything in the packet layer. So now it's everything Tofino ASIC switches or with the NoviFlow software. So those Tofino switches, they have full programmability. They support in-band network telemetry. They support virtual machines. They have 30 to 100 gig ports, so that helps our community to upgrade to 100 gig, because now a 100 gig port is a lot cheaper than it used to be in the legacy platforms. It has a variety of southbound protocols, OpenFlow 1.3, 1.4, P4 runtime, and also barefoot runtime. And the optical layer, since we're talking about a lot of spectrum and waves, we're talking about now moving everything to Wave Server AI and Wave Server 5 transponders. So those are data center interconnected devices. They also have stream telemetry, so which is a good thing, because then we can try to anticipate packet loss and disruption that could affect our users. And the main message is that this new data plan saved us a lot of money and OpEx for colocation, power, and maintenance, because now instead of having half a rack router, now we have routers that use 1 or 2 rack units and use a lot less power than before. So this is one of the main improvements. And for the intelligence plan, again, since there's a new thing, just a little bit of an introduction. What it does is, well, it gets the inventory, the policies, and then transform that into actions that will be followed by the control plane. So using, for example, examples of policies would be, if you have something that has more than 8% bandwidth utilization for more than 2 seconds, do something. If you have 50 or more percentage of key occupants for more than 2 seconds, do something. Or if the links are flapping a lot, do something else. So all of this that we used to do manually now is done, will be done by this framework in a completely software-related, software-driven approach. So how, just to finish this, how this is going to support the SAC community? Well, you saw that we have many links and multiple paths connecting the sites. So from Chile to Jacksonville and North Florida, there are more than 25 possible paths to take. So with the new architecture, we expect to properly load balance those services across those links, but at the same time that we respect the user constraints and requirements, which is driven by the new Pathfinder. We'll be able to handle any SLA-driven packet loss, intolerant, or sub-minute response time expected science application with the new INT solution. And we are trying to get ready to react to network conditions in the 1 second. Even if it's not a problem, if it's just seeing that the links or utilization increasing or the buffer utilization is increasing, we want to be able to do something with that. And with the optical telemetry, we can anticipate those issues, because in the optical substrate, you have those hard failures when you have a fiber cut or a power outage that the service stops working right away. But you also have the software issues when the conditions start deteriorating through time and not necessarily stop working right away, but you can see that it's moving towards a disruption. So you can anticipate this by using the telemetry provided by the optical layer. So that's what we want to do. If you see that over the course of 5 days, things are deteriorating, then we steer the traffic out of that link, out of that port, or out of that device before users start seeing problem. With the main focus is, well, our engineering team likes working with the new services. They don't like manual activity. So with the closed loop control, these activities, for example, load balance, that used to be very manual, now are performed by software. So we don't have to get involved in that, which kind of frees our software development and our development team to focus on new services, improving routines, or creating better policies or better monitoring tools. So this is what I had planned. Thank you for the attention, and open for questions.
Any questions or comments for Geronimo?
I have a question for Geronimo, and thanks for the talk. It was loaded with lots of stuff that I think I'm going to have to go back through and look over. But in the very beginning, you described, I think, AmLite as a distributed exchange point. Could you say a few more words about what you mean by a distributed exchange point?
Because what AmLite built in the past was the academic networks, they have their own like backbones, and they connect it usually through exchange points like AmPath. There's in Miami or mainland New York or Southern Light in in Sao Paulo, Zeoxy in South Africa. So those exchange points, they are in the same building, right? So, or they have one or two buildings, but they are like, the concept of the exchange point is a physical location, is a building where people go and exchange services. It could be phone calls, it could be IP packets, right? So what AimLite did was, the idea of SDN was that from the perspective of users from outside, they don't see the complexity of having to provision something from Miami to Sao Paulo, which is 2 exchange points, then to Chile, which is another exchange point, back to another exchange point. So they see this as a single thing. They see AimLite as a single academic exchange point, but in fact, it's distributed because on the layer, it's a lot of physical exchange points. So AimLite is more like a logical exchange point that is built upon multiple physical academic exchange points. So that's the reason we call distributed academic exchange point.
Thank you. That's very helpful.
Any other questions?
Sure. What is the actual policy in Kaitos written in? Is it like P4 or is it something specific to Kaitos?
What is what?
What is the policy? How are you actually developing the rules?
So today, the southbound is OpenFlow, as OpenFlow 1.3. Is a mix of OpenFlow 1.3 with 1.4 and experimental message. What we're doing right now is moving towards barefoot runtime.
Thank you.
But this is going to take some time, yeah.
This is Julio. I just have some comments to make. So one of the things that Geronimo has done very well this year is disseminating information about the work that we're doing on AmLite, and especially the automation and the closed loop orchestration, so that we start to let the network respond as it detects events that occur. So there's a number of presentations available through an engineering community called the Cyber Infrastructure Lunch and Learn. We'll go ahead and put some of those links in the chat for those of you who are interested in more information about the AmLite project and a complementary project we have alongside of it called the Atlantic Wave SDX, where a lot of software is being developed to do what Geronimo described as the intelligence plane and the management plane. There's been a lot of software development evolution over the last several years that we're really excited about, and we want to see how that those innovations will end up benefiting the SAC community. So we'll go ahead and put those links in the chat.
All right, thank you, Geronimo. If there are more questions or comments, we'll handle them this afternoon in the open discussion. And next up is Renata, who's gonna give an update on monitoring and measurement improvements on AmLite.
Good day, everybody. Let me just share my screen. Just a moment. Okay, I hope you are seeing the presentation, not the presentation mode here.
Yes, it looks great.
Okay, perfect. So I'm going to show some of the monitoring measurement that we have here at AmLite. We have a lot of tools that we use for a specific use. And I'm going to show how this can benefit the SAC community, not the SAC community, but our partners. And of course, we have the network visibility to know everything that is happening right now, and of course, have the historical data. And we use that information to identify the outage, to solve the outage, and identify the security threats too. And of course, recognize some points of improvements when we have some kind of link that is with high utilization, we need to improve it. So this is a lot of information. I will not focusing the details here, just for the information for you. We have a set of protocols and tools that we use at Enlight, and it all has its cons and pros. So we use each one of them with one focus. So talking about the S-flow, we use S-flow for the traffic analysis. We can use it to understand what is happening in our network, what is flowing in our network. So we can identify which source is communicating with which destination, which protocol port, which kind of protocol, and it helps us to understand what is going on in our network. So here we have some graphs that we can show for our partners, and you can use some kind of SLA tools to generate custom reports too. The persona, I think some of you know, I present the infrastructure last year. The persona is a tool that we use especially in the academic network, to run scheduled tests, especially for throughput, latency, and loss. We use this because this reflects the user experience, because we have persona nodes, persona endpoints in all our major sites, from Chile to Brazil to Miami, and also now to Africa too. And we can measure the experience for the user. So you can see here that we have a graph for the latency and for the loss. We have some kind of event, and the latency dropped and then increased. Okay, something happened here. The user is experiencing this kind of change in the latency. But we, of course, we don't know yet what is happening, but we are going to use all our tools to identify the root cause. We have telemetry too. Telemetry is a new way of getting information from our devices. We can use SNMP, all our devices use SNMP, but the telemetry is something new. We use in our Juniper Horus, that is using the Juniper telemetry interface, and we can stream, we can send the information each 2 seconds. And the sensor for the telemetry data is near the source of the data. So the impact for the device is really low. So we can easily scale this information. We can have a lot of information from the device and sent to a central server. And of course, we have INT, the in-band telemetry that Geronimo just mentioned before me. We use this in our network right now in production. We have all the packets that is having the metadata inserted in every packet, and then we report that, and we can see all the results almost in real time. So just show you an example here in the graph above, we have the INT data, and below we have the SNMP collecting every 15 seconds. So we have the same traffic. This is the same traffic, the same interface, the same time, but here we have more information because we have the interval for this graph is just 200 milliseconds, and this is 15 seconds. So we can see here that the utilization reached almost 40 to 50 giga, but here in the SNMP, we just see 12, 13 gigabit per second, okay? So this is really helpful. Talking about the monitor tools that we have, the major solution that we have is Zabbix. It's a well-known tool, it's open source, and we have a lot of templates that is official from Zabbix that we can collect for the major vendors that we have in place. And we also have an agent. The Zabbix has an agent that you can install in your server and then collect data from the server. And the most powerful thing from the Zabbix is the custom scripts that we can develop. But we have a lot of custom scripts, and then we collect that data using netconf, REST, gRPC, and you can display this information with the other information that we have in Zabbix collecting by SNP and other forms. So we have integration. I can talk about the Slack because this is very important. We have alarms on Zabbix, and the Zabbix send that information to Slack. And then we have some groups inside the Slack, and we have the information, especially the most important issues that we have in our network. We can have this in our smartphone. And of course, we have all the historical data in the Zabbix too. And something that is very important right now, not just for our community, but for the internet at all, is the security. We have some kind of tools that we are deploying, and we have some other ideas for the future too. Right now, we have a honeypot. Just a quick explanation, is a server that is intentionally compromised, and then we open this server for the internet and we receive attacks, and then we store that information, analyze the information, and we check if we need to make some changes in our network to apply some kind of filters, firewalls, ACLs, or to report to our partners too. We monitor our BGP routing table with some of our partners, the Cimeru. We have monitor of DOS and the DOS events. And of course, with all of that, we have some kind of threat intelligence. Continue with security. Now we are part of the Manners Initiative. It has been done since the end of the last year. And this is for improve the security in the internet routing network. So we have 4 actions that we have to be compromised to enable in our network. We have the filtering, prevent propagation of the incorrect routing information, and spoofing to prevent with that fake IP address, the fake source IP address can be used. We have the coordination when we make our information available for the community, for the internet community. And we have the global validation that we use, the RPKA. That is very important because we will make sure that some of the routes are really from that source ASN, for that organization. So this is really very important. And you can see here just a dashboard for the Manners. We have all the information from the participants. And you can see that only 28% of the participants has a RPKA, and this is something that we already have in production in our network. And of course, the RPKA is something that we coordinate with our partners, and we have that information in our website that everyone in the community can use that information, not just the MLite, but all our partners can use that information to treat this kind of network security. And just final comments. We have a rich set of tools to monitor our infrastructure. I didn't mention everything. We don't have time for that, but it's very important. And we have a dedicated Zabbix server for the Rubin Observatory. This is a working in progress. We have a lot of things to do there. Probably we are going to make some of the observations here in the net meeting. The persona results are public. Everyone can access. We have all the links here, okay? And we have a status page. The status page is something very accessible because we are going to tell our community that some event is happening. It's not technical. So we have a problem between Chile and Brazil. We are going to tell that we know that we have this problem and we are working on it. We have the myamlight.net that we can see the interface utilization of our network. And just some comments that I added here because the in-band telemetry is very important to us, like Geronimo just said. And of course, this is going to improve a lot of our measurement and our monitoring. And just to end, monitoring security is a must today because it's really important and it's something that the major network companies doesn't make some attention to it, but we are working to get better monitoring security. So I think that's it. Thank you. I'm open for questions.
That was a very nice presentation, Renata. Anybody want to start the questions? Okay, I'll ask one. When we're collecting all of the in-band network telemetry, that's a lot of data. How much are we keeping and where is it?
Wow, this is a trick question. I'm
I
not sure how
apologize.
much. I'm not sure how much, how many time we are storing this information because we just put this in production, so we don't have so many mouths of data. Maybe Geronimo has some information for that, but it's tricky. The idea is not to store everything, but to store events. So we are going to monitor everything, but not store everything. So, but this is tricky because it's a lot of information that we have.
And
Yeah.
is this storage at AMPath or at multiple exchange points?
Yeah, it's right now at Miami, inside our network, in some of our servers.
Let me comment on this. We have 80 gigabytes of data every 3 months. Yeah. So that's how much we store. And our retention policies is forever for now.
Okay.
Let me just add as well, Heidi, that the storage will be distributed. There's going to be telemetry collectors at the exchange points where we have all of the programmable switches. So that will be distributed.
Okay. Well, we're actually ahead of schedule. So
Well, I have a couple of comments if there's no further questions.
Okay.
I just wanted to first of all compliment Renata for a very good presentation on the instrumentation that we have on AmLite and continue evolving. I just want to emphasize that with the instrumentation that we are deploying, it's going to give us the capability of broad monitoring and measurement using tools such as perf sonar and other traditional tools that are based on sampling, such as SNMP, SFlow, and different type of sampling tools. But we're also going to have deep visibility with the instrumentation. So it's a paradigm that provides us with broad monitoring and deep monitoring and measurement capabilities that we will have the ability of capturing every event that occurs on the AmLite network to be able to respond to different kinds of policies for the science applications. So we're really looking forward to working with the SAC community and being able to demonstrate some of these capabilities.
I have something to add to that. Thanks, Julio. So from a user point of view, like Ruben, how do we envision seeing, summary reports or information from all this monitoring?
Well, we have, like I said, we have a Zabbix with the information with interfaces and something more. I don't remember right now everything that we have there. It's open too. And you can use the persona right now. Well, everything that is open, you can use it. But of course, this Zabbix for the Rubin Observatory is going to be more rich. We are going to add more information, probably on Friday. I'm going to talk about that. And we are going to have a lot of information there. And the int in the future, we are going to use that too.
Bob, this is Jeff.
Let me just make one comment. I'm sorry, Jeff. Go ahead.
Yeah, I was just going to say the intent of the virtual NOC is to pull information from all the different operators, including this AmLite type information into a single portal for Rubin.
Thanks.
Yes, yeah. Well, let me make a comment on this as well. So we have this Zabbix instance that was built to support the VNOC, to be like a prototype. This is specific to the Vera Rubin. And the idea is to gather data from all the participants, and then in the future, the VNOC takes over the operation of that node and that service. But the access to the INT data, to those reports, this is something that in fact was triggered by Vera Rubin, by LSST back in 2018. The data management team was the one that was asking for more granular visibility of the network. And there were multiple conversations with KT. I think Jeff participated of some of those discussions as well. Where KT was asking, can I have this kind of visibility every second? We never, when we tried to design like a common interface for KT and the data management team to have access to the data, there was no clear idea how this would work, if this would be integrated into the data management applications, if it was just going to be observation, if it's just going to be an email. So there was no further discussion because of everything that happened with the Rubin project, but that data will be available. So there is multiple interfaces to query the data. There is approaches for Vera Rubin or any other participant to receive the data almost in real time. But also that data is stored in a database. So if you want to go back and see what happened last night, that data will be available over there. But then you can run the queries yourself.
Thanks. That's all very helpful. And then apart from all of that, which maybe is enough, and then when Jeff says we're going to set up the VNOC and have kind of a summary view of everything. But do we expect to get, regular reports quarterly or annually about the performance of how things have gone?
We did this
the monthly reports have measurement data.
Yeah.
And the annual.
Do we get those now? I don't remember.
Yeah, I copy you on them, Bob.
Thanks.
Yeah, we started in October for measurement data. Yeah.
Yeah, we can customize those reports, Bob, as well. Right now, we are providing measurement data with the monthly reports.
Well, I'm sure I'll pay more attention when there's actual real data flowing regularly.
All right then.
We have one more questions in the chat actually from Samchan.
Okay, Sam, why don't you go ahead and ask that?
Yeah, I was wondering if you have multiple internet connection from other provider that's not AmLite, do you monitor those as well? Like into the Rubin observatory, if they had different provider that providing backup circuit and stuff like that.
Not exactly, just up to our endpoints. So we just measure our network, but of course, the Rubin Observatory has its own Grafana, has its own measures. Maybe in the future, we can use that data too, maybe using some kind of SMP proxy. But right now, no, we just monitor our part. But with the persona, we can have this kind of experience. We can have interdomain tests. So we can test from, I don't know, maybe Brazil to Africa without any problems. So we have this kind of monitoring.
So just to add to that, Sam, what Renata is referring to is with Persona, we have a dashboard that represents all of the different network segments that are managed by all of the operators that are part of the community or the SAC community. So we can make that available to the users, as well as if the users want to see a particular segment that's not there, it could be added to the dashboard. Sonar has become pretty much the standard measurement tool for running a suite of different tests for being able to measure performance and to monitor network segments. So yes, we have that capability.
Okay, thank you.
Okay, let's move on to our next presentation. Shukri Wiener is going to present on Sanren and our South African partners.
Thanks, Adi. Hi, everyone. All right, so today I'm going to give an update on the SA NREN connectivity progress has been made through 2021 and 2022. We can touch on the international connectivity and just everything that's happening across the country. All right, so just the SA NREN is comprised of two parts, the TENET, where I'm from, as well as the SANREN team. So both organizations work together to create and deliver the services on the NREN. The SANREN team is responsible for the design, acquisition, and rollout of the national and international capacity. There's lots of overlap between the organizations. TENET's main focus is to secure IT services and internet capacity for the benefit of SA universities and associated research and support institutions. So the teams work very close together. In fact, there's not much on the network that we don't participate in together. Get this going. All right, so I'll touch on the international activity, how things are connecting from Africa out to Europe and the South America and the US, as well as where we currently connecting at the exchange points, how things are looking for connectivity on the African continent, as well as the work that's been done nationally to improve capacity. Right, so things have been slow on the international front. Since the updates we've done last year, we are still holding for the activation of 100 gig circuits through from Cape Town to London, as well as from Mzini to Amsterdam. Most of the delays are process driven, as well as just hardware, just ordering delays as well that has creeped in. Our backbone, as it stands, is we have capacity running around the east coast on the CCOM, and easy capacity, as well as on the west coast. Let me get the laser going. As well as the west coast, we've got the WAX capacity going up to London, and that interconnects between Amsterdam and London. We then also have WAX capacity going up to Angola, and then across to Fort Laser and up to Miami as well. Right. So exchange points, not many have been added or to the international networks. So we are still at the same points we were at last year. The interconnects to these points haven't increased either. I think once they set up to our various international partners, everything just grows from there. After that, it's just about increasing capacity wherever it is needed. On the African continent, the AfriConnect 3 project that is steadily moving forward. They're currently procuring more capacity between African countries, as well as connecting new NRENs to that segment of the network. We are holding for the Abuja Alliance to create the Johannesburg node. Hopefully that happens within this year. And at that point, we'll have an interconnect at that location as well. Our friends at Bahrain are still working on their link to get from their country to from Nigeria to Cape Town. This is something that still is in planning, so I think it'll take some time to get completed. All right, let's move on to just the national activity. So the SA-NREN, we connect all the universities and research councils in South Africa. The network originally started as just a multiple 10 gig managed link network, and has steadily grown to multiple 10 gigs a DWM network, as well as managed 100 gig circuits. So at the base of the network, we've got our DWM system. This is dark fiber that's spanning from Cape Town all the way through to Bloemfontein, Johannesburg, down to Durban, and then a spur coming down from Bloemfontein to East London. We have a segment that still is under construction to Kibera, as well as the spur that will go up to the Sarau Carnarvon pop, which I'll touch on just now. So we've deployed a 96 channel system that's gridless and directionless using ADVA equipment. Right now, our long haul segments are using 100 gig transports as well. And then in our metros, with distances are shorter, the cards are able to give us 200 gig transport capacity. So this footprint touches all the major institutions in our country. So we'll zoom into what's happening in the Northern Cape to get us to the Karoo, where the Sarau SKA node is. Right, so as we go into this, so there's a segment we're building. So the purple line here is the existing DWM network that's in operation. At Beaufort West, there's the orange line is new fiber that needs to be built going up through to the SKA Carnarvon pop. So there's about 164 kilometers of fiber needs to be built. The procurement process is still moving along. All the environmental impact assessment work has been completed, and we're currently now in negotiations for way leaves to trench along the public roads. Right. So this is a simplified view of the end DWM network. Essentially, I'll show the path that's in place to the Carnarvon and the Eastern Cape. What you'll notice here is that there's segments between these nodes that haven't been closed. So that wasn't possible at the time of the procurement of this network. So we were looking at 100 gig managed links, and managed links here is circuits purchased from carriers to assist with closing up these loops. So what we're doing with these is that we're looking at alternate routes. So essentially our DWM network follows the railway paths, where let's take the circuit going from Cape Town all the way to Johannesburg. This follows the national road going in that direction. So with these blue lines, 100 gig managed circuits, these make certain that essentially if there's a break on a DWM fiber, that there's still some path to close the network. All right. So once the DWM network was built and we got all the managed circuits in place, the next thing we had to focus on was to get our routing equipment upgraded. So we essentially have to touch all nodes within the network, and this has been ongoing since early 2020 and 2021, and we're down to 3 nodes left that needs to be completed. Our previous network was a 100 gig platform, and in production. Some locations we had to do a forklift replace of equipment and put something in exactly the same position. Other places we were able to rebuild the node in the rack next door and just migrate services onto there. It was quite something when we had to do complete shutdowns. Essentially, there was just no going back. There's no rollback plan. Essentially, shut down, rip everything out, and replace all components and get everything up and running within a few hours. We chose the SA-NREN team chose the medium density 100 gig MX10003 platform. What this gave us is two line cards with 6 QSFP ports on the side and interface card with QSFP28 100 gig ports in there. So this chassis is like a Swiss Army knife. We're able to terminate everything down from 1 gig. Client links all the way up to the 100 gig circuits that needs to be terminated off our managed circuit links as well as the DWM equipment. So this is a view of one of the nodes. So we compressed our 10 gig nodes from 21U rack unit footprint down to 7Us. And how this rolled out is that we've got a breaker cable. So you may be aware of like an octopus cable that comes out of a MPO connector. It breaks out into 4 LC cables, so that's very messy and it's prone to damage. So this is a MPO patch panel that simply connects MPO to MPO cables to each other. Each port here then gives us 10 gig capacity. What we've done as well is that we also need to connect our 1 gig services that were existing, as well as just to connect smaller sites. What we've done here is that we've got the Juniper EX4300 satellite nodes. So these nodes connect into the main chassis, and they are controlled by the main chassis. In fact, when you log onto the device, it just looks like it's another line card. So we can configure all the services that we normally configure, and only from one location. No need to do VLAN spanning or anything like that. It just looks like it's a service directly off the main chassis. The only issue we have is that you can't connect any backbone circuits to the satellite node. It doesn't allow for the general transport that you require between backbone nodes. It's only useful for connecting client edge devices. Yeah. So that's the upgrades that have taken place in South Africa. I think we're now moving to our attention to the smaller sites, trying to get all the older end of life equipment removed and upgrading them to either Juniper MX10003s or to MX2000 to MX204 devices. Yeah, so that's all from my side. Thank you very much, and I'm open to questions.
Are there any questions? Maybe Shukri, you could comment a little on the conversations we've been having to try to track the astronomy data flows between the Meerkat site and NRAO and other users on the US side, like at Rutgers.
I mean, the first thing we went looking at was just make certain that the routing was specifically going across the SACS path and not via Europe. So initially, when we set up the circuits and just left routing to take its metrics to take its the dynamic paths available at the time, most of the traffic would go via Europe to get to the US. So that all has been changed, and now it's pinned down to ensure that the lowest latency path directly over SACS is the path that's used between the two countries.
Good. I know when we started our connection, we made sure that the perf sonar was in place, and that seems to be working really well. This is more towards Geronimo, but do you foresee a time where we'll put a NovaFlow switch in Cape Town? Or Julio?
I think that is on the roadmap, but we need to further make plans with Shukri and see how that will fit into the work that we're doing with AmLight and the SDX project. Yeah, I think there definitely will be some new features and capabilities by being able to add a P4 switch there in Cape Town.
Cool. So yesterday there was a question about the NSF involvement with Meerkat or SKA, and I wanted to follow that up very briefly. It seems like NSF is supporting PIs, principal investigators in the US, even if they're not directly involved with, the setup of the sites and so forth. Anybody want to comment on that? Or I'll just keep digging. Okay. All right. Wonderful. Thank you.
I can comment about that. So it's just the usual standalone grants, right? So there's no consolidated NSF grant for Meerkat or SKA involvement. It's really just the standalone grants that are open to the average researcher, and they use those NSF grants to work on Meerkat.
Yes, well, that's good in my opinion. So I want to thank you so much for your presentation. And we're going to move now to Reuna in Chile. Albert, are you ready?
Oh, Heidi. Yes, I'm
Hi.
going to share my screen now. Please let me know if you can see it in presentation mode.
Yes, it's good.
Okay.
Nice picture too.
Thank you. Thanks. Good day to everyone. My name is Albert Astudillo. I'm the technical manager of Reuna, which is the Chilean Research and Education Network. Throughout my presentation, I'm going to be talking about a little bit about ourselves, the current infrastructure that we have, the synergy with the astronomical community, and some of the projects that we are involved for the future. Okay, so Reuna is a non-profit corporation that has been working in Chile for more than 30 years on the digital development of the Chilean research and education ecosystem. At the moment, we have 45 organizations connected to us with more than 9,000 kilometers network infrastructure that actually enables more than 80% of the research that is made from Chile and interconnects more than 400,000 nationally students and academics. So we are a fairly small institution, only 20 people work in this institution, and this is our current infrastructure that expands from Arica on the north part of the country all the way up to Puerto Montt. The capacities that we have at this moment goes from 10 gigabits per second all the way up to multiple 100G in the center part of our infrastructure. Unfortunately, Chile is a very let's say Santiago dependent infrastructure, so all the traffic that goes outside our country are landing in Santiago, so our infrastructure behaves like a bus. So all the links that goes towards Santiago are a little bit thicker than the ones that are in the stream. So since the last SAG, I would say, or since 2020, all our efforts were focused more on the northern side of the country, in the connectivity between Antofagasta and Santiago, which is the part that most of the astronomical projects are connected to us. During 2021, most of our effort were put on the southern part of our network, and one of the key concerns that we have as a research and education network is the reliability and the availability of the services that we provide. So as you can see here, most of our network has at least a couple of links that interconnect each of the points. So the key point here is to have the best possible availability of the services. This is carried out by our in-house NUC, which operates 24/7. And at this point, we have 18 points of presence that are located pretty much in the capital of the regions that we have at the moment connected. Okay, so what's new from the last SAG? One of the key points that we worked in the last year was the improvement of the connectivity in Las Campanas. The idea here was use the synergies of the infrastructure that we have already in place, and we managed to open the connectivity that the observatory has in the mountain to the offices that they have in La Serena, and open this connectivity using the equipment that we have already in place in the service provider. So the idea here is, on the one side, increase the availability that the observatory have to connect to their offices, because we have a lot of dark fiber between in La Serena connecting to Aura, and on the other side, expand the possibilities for other initiatives that might happen. For example, I heard yesterday from GMTO that they are located very close to Las Campanas, so this might be at least from a technical point of view. Today, there exists a very good scenario to make some tests if they need. And so I think this kind of synergies that we work and don't require a lot of effort are very good for the entire community. Another work that we have done since the last SAC is the increase the capacity or the services that we are transport over our metropolitan ring. The metropolitan ring is the infrastructure that we have in Santiago to connect the 5 major points that we have for the international connectivity and also for our one of our more important partners, which are located in Vitacura, which are the ALMA offices and ISO offices. So what we do here was to implement new services from Vera Rubí, the 100G that goes from Huechuraba to Compañía, the new 200G traffic from Red Clara that is also coming from Compañía, and we increase the connectivity that we have with Red Clara. We pass from a 10G channel to a 200 gigabit traffic between our institutions. So at least from an international point of view, we have a lot of capacity at the moment, and the metropolitan ring has obviously more capacity to expand, and this has helped us a lot actually, because probably same as the rest of the world, we have a lot of cuts, fiber cuts here in Santiago. So the metropolitan ring has served us well in terms of protect the traffic when we have some kind of fiber cut on any segment of the ring. As I said, the 2021 was majorly focused on the southern part of our network. So we built a new link between Santiago and Concepcion using a direct link, a new point of presence in Curicó. We enhanced the protection of one of our segments between Chillán and Temuco, adding a 1+R protection, and we upgrade the capacity from Temuco to Puerto Montt to allocate a 10G protected services, and we increase the capacity of our backup link actually, because Chile is so thin. There has been some events, especially because of wildfire, that the fire burns all the fiber that we have, even in very distant in terms of Chile, very distant path. So this Argentina backup link has helped us to provide the service and help us to, in case of this event, to have a way out of the traffic to connect to Chile. So this is a very key infrastructure for us. Okay, so what are the projects that we have at the moment? At the last SAC, I talked about the great depth that we have for the connectivity in the southern part of Chile. At this moment, well, I'm using a very old graphic for the infrastructure of research and education network, but unfortunately, it's still valid for the southern connectivity that we have at the moment. But today, we have the opportunity to join efforts with ANID, which is kind of like NSF in Chile, and the Minister of Science to build and to reach this farthest part of the country, enabling new connectivity. The idea here is to connect Coyhaique and Punta Arenas, which are the most important cities in those two regions. In the past presentation last year, I talked about the idea was to use the fiber optic Australian optic fiber in English, which was the Chilean project that built a new submarine cable to connect those areas. Unfortunately, there were some issues that arise, and what we decide is to start the project using service providers that reach the areas, but we keep in mind to at some point of the project migrate this traffic to that submarine cable. And at this point we have an initial operation time frame from 2022 2027. This is 5 years of operation, and but the idea here is that this is going to be only the phase one of this project. And the current status is that the link to Coyhaique at the moment is under construction, and the link to Punta Arenas is going to be implemented during the second semester of this year. So by the end of this year, we will hopefully, finger crossed, have the connectivity reaching these two farthest south of the country, which it is something that we are very excited about, because I think that every NREN has in their mind to be able to reach all the regions of the country. So I think that we are going to be fulfilling a dream for us. So we are very happy about it. The other project that we are working on it was mentioned yesterday. It has to do with the research and education point of presence in Changnator. Of course, the idea here is to be able to provide connectivity for the observatories or projects located in the Changnator Valley. The current status is that the agreement is almost ready to be signed. Actually, it's almost waiting for the signatures to be done. The initial capacity that we are foreseeing now is a 1G, but it's going to scale over time. And this is going to be the escalation of the bandwidth that is going to be in the time frame that the astronomical project requires. So this is something that we are also going to be working together with ALMA. And the intended implementation date for this point of presence is by the end of this year, hopefully. All of this is made by a collaborative way. I think that everyone that is involved in the project is adding some infrastructure that they already have. The idea here is that ALMA is going to provide a segment of their filament, and then the observatories, or in case of the Cerro Toco, the Atacama Astronomical Park is going to be building the final, let's say, the final last mile that are going to interconnect with the ALMA facilities, and from there we are going to be ready to implement the connectivity with both of the mountains. So at this point we are talking with CICAD and the partners of Cerro Toco to reach the technical agreements to engage in this project. And as Mike told yesterday, one of those steps was to make a simulation of the point of presence that is going to be there. So this was built thanks to Alma Health, that enables to build the 1G connectivity between AOS and Antofagasta, and provide us with the remote hands and the laptop to make this test. And from there we connect to Riuna using our 100G capacity. So the test was using obviously Alma and Riuna clouds, and the test was all the way until the University of Toronto. So we pass over the Canary infrastructures as well. And as we have a bottleneck of a 1G, well, the performance that we have was around 900 megabits per second, except for the download that we have using UDP, that we think that was related with a bottleneck of the same laptop that we use, that we only foresee 750 more or less megabits per second. But in terms of the network behaved really well. We didn't find any issues. So I think that was a successful simulation, and we are very happy that this is the first step in order to fulfill this. this achievement. Of course, we are partnered with the more important international connectivity projects for research and education. We are partnered with Scala. They provide us with the international academic. They also provide us with the connectivity for public clouds and connectivity, such as Google, Amazon, and Microsoft. We have also being part of the Bella project, which I'm pretty sure that Luis is going to talk about in detail in a few more minutes. But since the cable is in place, Red Cloud and we did a very quickly job to enable the connectivity using Bella. So actually today all the institutions that are connected to Riuna and need to get to Europe are using the Bella project at this moment. So this is great news because we have more bandwidth and lower latency times to get to Europe. And an important point here is that we, Riuna, as a partner of the project, we have already built the connectivity between Santiago and Antofagasta with a couple of 100G links that we hope to expand all the way up to the west coast of Latin America in order to close the ring in Latin America and have a protected traffic for all the partners involved. We are part of AMLIGHT as well to provide the connectivity for important projects such as Vera Rubin. So we are very well connected in terms of the international connectivity. So in terms of future projects, probably some of you have heard that the Chilean government is carrying out the installation of a new submarine cable that is going to be the first cable that unites South America with Oceania. The technical feasibility of that cable has already done and gave us the number that you have on the right, which is going to be more than 14,000 kilometers with approximately 400 million CAPEX for the implementation in a public-private consortium with 25 years of operations. And the idea that we have here as Riuna and as Latin America is to work on this initiative in a similar way that we have in Bella. So ideally, the work that we are doing here is to be able to have some kind of spectrum on this infrastructure in order to connect these two continents, and we think that it's going to have a major impact, especially in the astronomic area, because of the partnership that most of these projects has with infrastructure that is in Oceania. So at the moment, it's a very important project for us, and we are working on it. And last but not least, with the Patagonia project, we think that we are making the first step to be able to connect the Antarctics. We have been involved with a lot of governmental initiatives. Actually, the Chilean government has commit the resource for the first technical feasibility for the cable of that will go eventually from Punta Arenas to Antarctics. So this will be the first step. There is also a lot of other initiatives, such as the construction for the International Antarctic Center that they allocate a lot of projects. So we think that with Patagonia, we are making that Punta Arenas is going to be the gateway for all these amazing projects that are happening in the Antarctic. And surely we are working hard to make that this Chilean southern zone could and not already is as a science ball, but it has the connectivity that needs to carry out all these amazing projects. So this is on my side. I'm very happy to answer any questions that you have.
Hi, Albert, it's Chip. Could you talk a little bit more about the causes of the delay to access the submarine cable from Santiago to Puerto Arenas?
That was a really headache for us, Chip, last year, because we worked with the telecommunication minister for, I would say, 18 months in order to reach access using that capability. But unfortunately, there are some, I would say, legal problems related to the use that we could make if we use that infrastructure. So to say in a most plain way, we couldn't provide services just like internet over that cable, because that might be arouse account against another internet service provider. So that
Yeah.
so that put us in a very hard position and endanger the project. So that is why, at least at the first stage, we want to go over traditional providers and avoid that kind of issues that might happen.
So, but for purely research education purposes, do you expect that you would have access to spectrum to self-light on that cable, or what do you think the handoff would be?
No, actually, we were as the Chilean government give the funds for the construction of the cable. They have part of the spectrum relate that they reserved. So we want to use that part of the spectrum, because it doesn't have any cost in terms of the use of the infrastructure. It has other costs that come to reach the POPs, but that at least is an idea, because today we have a new government. We are trying to see if some of the policies that we have on the previous government are still maintaining this one. So it might be a change on that regard.
Great, thanks.
Christian?
Yes, Albert. Hi.
Hello.
I saw 3 links from Santiago to La Serena. Are those our 2 links plus another one?
Yes, actually there are there is the LT3T that you know very well, the fiber that connects through Santiago La Serena. We have the 100G capacity that we are using actually to back up the variable link, and we have a node capacity also that is made of 10G that is also running in between both nodes.
All right. Okay. And have you considered using submarine fibers to the north of Chile, Santiago to the north?
Yeah, actually, we talk a lot with the service provider that ran that cable, but unfortunately, the prices that they gave us was ridiculously more than we have at the moment, and as the cable lands in Valparaiso, we also need to protect the connectivity from Valparaiso to Santiago, so it wasn't an easy project on that side. Oops. Christian, it seems like it's
I'm here. Something's
okay.
going on with. I can hear you.
Okay.
I'm stuck.
Yeah, yeah, but we do require some proposal from there, Christian. But unfortunately, at this point, the project is too new, so I think that they're trying to get as much as revenue as they can. So the prices are crazy, at least for us.
This is WOM, right?
No, actually, it's GDT.
Oh, really? All right.
Yeah.
Okay.
Yeah.
All right. Great. Thank you.
You're welcome.
So Albert, I was wondering, in the build out around Alma, where you have that 1 gig bottleneck, why is that? Is it just a matter of the equipment that you're using to light the new cable?
It has to do with the agreement that we have at the moment with ALMA. The idea is to share the infrastructure that they have connected AOS to Antofagasta. So at the moment they are sharing 1G with us, but in the agreement we have the availability to ask for more. But the idea there is when the time comes to make investment in expand the infrastructure that they have also, because as Christian said yesterday, they're using a DWDM system that is kind of old at this time. So probably when that equipment is upgraded, we are going to be installing a separate Lambda from us, and that will give us more bandwidth. But the 1G is only a starting point. The infrastructure is not going to be a bottleneck, because the idea is to make the investment when in the more efficient way, and when each of the projects are going to need that capacity. So
cool. Any other questions at this point for Albert?
I just want to make a comment to Albert, just to compliment him. Very, very nice presentation, Albert. A lot of progress since the last year. That's really amazing work. So thank you for the update.
Thanks, Julio. Thanks for your kind words.
Okay, so we're going to move on now to Red Nest, Sao Paulo. Jeff, are you ready?
Okay. Okay, I'm sharing my screen. Can you see my screen?
Yes.
Okay.
We see your desktop too.
Yeah.
There, that's it. Thank you.
Thank you. Thank you very much for Julie Barra and the AMLIGHT meeting. It's important Red Nest here. My name is João Eduardo Ferreira, or my nickname is Jeff, but pay attention, only one F, not two, because Jeff with two F is another important person than me. I have a quick presentation about research and education network at São Paulo. I described three main efforts. Then, first of all, it's important to note that there is an important change, governance change in the state of São Paulo. Before we have academic network at São Paulo, named ANSP. Then ANSP is divided into two organizations. The first organization is a ReadyNesp, the Research and Education Network at São Paulo. This organization is managed by three important universities in the state of São Paulo: University of São Paulo, São Paulo State University, and State University of Campinas. These three universities compose the committee that manage all activities of ReadyNesp. On the other side, you have academic committee. This is a kind of scientific board managed by FAPESP with astronomy and physics teams. Basically, the ReadyNesp is talking with IT things, and the academic committee is talking about astronomy and physics issues. It's important to note because this is a different approach. Before of ANSP, you have only one person to manage. Now we have an important university coordination for a lot of IT activities in ReadyNesp. Let's go to the three effort. The first effort is the financial investment. Government of São Paulo has invested around $5 million a year in the last 50 years to provide for providing Atlantic and Pacific links. You can see using orange lines here in the AMLIGHT partner cooperation and the ReadyNesp connections. This financial investment is funded by FAPESP. FAPESP is the financial agency at São Paulo, the São Paulo Research Foundation. It's important to note that in the last 15 years, It's not easy to do this because, you know, in the South country, it's not easy to do this, South America especially, and then in pandemic side effects also is not easy. However, every day you insist in this first effort, provide a financial investment for international connections and improve the networking in state of São Paulo. Our second effort is related to the technical collaborations. In this presentation, I highlight 4 tech collaboration. The first has the management of international connections. You have, you know, you have 3 main points here. The red contingency point is related to the alternative link in case of a problem in our orange or blue links. You have a contingency point, the alternative link for internet commodities. These connections also is funded by FAPEST and REDNESP. In yellow, you have resilient links that use 100 gigabits per second. This link is less than 10 years or 12 years, is funded by FAPEST REDNESP and provided by Laurin. And we also have another Lambda channel for our responsibility that is provided by Amlight Cooperation, and these 3 points, red, orange, and blue, is our international connections, and we have to management of international connections for our users. Our second tech collaboration is related to integration important institutes and universities in the state of São Paulo. You have around 36 institutions and research institutions and universities that link use our services. Then it is important. You can see here, this is the state of São Paulo. And then here you can see 3 cable, 2 link, orange link from Laurin and another cable, Monet cable. This cable is managed in our network to provide international links. This is our second technical collaboration. Our third collaboration, as Geronimo and Renata said in last presentations, our collaboration, readiness and light, is wants to provide as kind of logical connections in physical cable. More concretely, Amlight proposed to improve the SDN framework to add new network functions to support SLA-based science drives. Our effort, called the Kitos SDN, is a platform, it's an open source platform. Controller if ever work as a microservices. Kitos software or Kitos platform acts as a repository just like any Linux packaging system. Kitos starts as an open source project funded by State University of São Paulo to manage the data transfer between their labs, fully writing Python. The Kitos community has been developed many application libraries, including for OpenFlow. This project is led by or coordinated by Amlight, especially for Geronimo. And the main goal of the Kitos is create for replacing all L2 VPN application. You can see the screen is extracted from Kitos softwares. This is a kind of logical circuits. And here in this picture, you have the yellow layer that Kitos SDN platform is our contribution with Amlight, especially for logical circuits. Another technical collaboration is related to the global network advanced globe. You know that GNNG is an international effort to connect many research and education networks on a global scale using the best technology to help meet humanity's challenge. Readiness, having been a member for some time now, we are interested particularly in GNR data intensive science. And the main idea here is to collaborate with RNP and HEDCLARA to establish a new connection link in São Paulo to CERN laboratory in Switzerland that shall be a new of autogol sense test bed. This is a new initiative. It's a kind of international initiative that involves many groups in this effort. And the third effort and the last effort, but this is our main progress in last year. Now, Readiness and FAPES is providing an important backbone. The name is Backbone São Paulo or Backbone SCP. We begin with 100 gigabits. The idea not, but the implementation now is to integrate 8 important universities, such as Federal University, State University in the state of São Paulo, using 100 gigabits per second. Why this backbone? The backbone, there are 2 goals. The first goal is related to the AGPC functionality. FAPES want to go to maintain 100 gigabits between this university in order to provide supercomputing functionalities and share education models, education data that are developing in this university. This is a big challenge. However, in November of this year, November 2022, we want to begin the operations. Now you contract the company to provide this link, and I hope in next presentation, or maybe in next meeting of AmLight, I will give you more details about this important backbone. I think this is that's all for today. As said, we are in a change of government and governance connectivity in the state of São Paulo. And but I hope that the historic contribution at the ANSP and the Readiness in AmLight umbrella is a good way to improve our connectivity in international connectivity and internal connection in the state of São Paulo. Thanks, Julio.
Oh, thank you for
Jeff. It's Chip.
Yes?
I was kind of, hey, Jeff, on the last slide with Backbone SP, is that what you all are envisioning the topology will look like in November? Yeah, this is our goal. This is our goal to begin our activities in November and this year. This is a kind of important strategic infrastructure in the state of São Paulo. This is the main idea. Okay, thanks.
So Jeff, the work at UNESCO, which is high energy physics, do you see currently some overlap with the new projects coming online in astronomy, like the Vera Rubin Observatory, where there'll be more dark energy, dark matter discoveries?
It's a good question. The main goal of the Readiness is facilitate all interactions between universities and provide the better connectivity. It's our main goal. You know, sometimes you have a state and the federal conflicts, but we can survive. And it can survive, and it can, with AmLight umbrella, it's a good way to solve this problem in this kind of noise. This is the main answer.
Well, certainly the efforts or the contributions to Quito's NG that your team is providing, I know it's very valuable to our community.
Yeah.
Yeah. So we're just up for a break. So why don't we start that, and everyone can get some refreshment, and we will come back at 13:20 Eastern time. Okay? And we'll hear from Red Clover. Thank you.
Thanks.
Thank you.